The government has invested millions of dollars in research and development to better understand the brain. Part of that money has gone towards developing brain computer interfaces, which allow people to control machines using their thoughts. Karen Howard is the Director of Science, Technology Assessment, and Analytics at the Government Accountability Office. Karen, welcome to the program.
Thank you for inviting me.
First, can you explain what a brain computer interface is?
Sure. A brain computer interface is a device that's designed to read signals that our brain is producing during normal activity and translate those to cause another device to move. So, for example, it might help somebody who is paralyzed use their brain to control a prosthetic arm or even to learn to regain control of their own limb.
And how does it actually work? Is this a device that would be implanted or is it wearable?
So both kinds of devices exist. The wearable devices typically use a cap or a headset to pick up the brain activity from outside the skull and then translate that to the device that helps with the motion. An implanted device would be implanted directly on the brain tissue. This would, of course, require surgery into the skull to insert the electrodes or a more recent device uses a stent type electrode that is fed through the jugular vein up into a vein in the brain.
And how long has this technology been around? I mean, how far along is it today?
Wearable brain computer interfaces have been around since the early 1970s, and they've continued to advance since then, and researchers are finding additional applications for those. Implanted brain computer interfaces were first used in humans, implanted in human brains in the late 1990s. And at the current time, those are all still in clinical trials. There are no implanted BCIs that are available on the market.
And when people think of machinery connected to brain signals, they usually think about prosthetic limbs, which you mentioned before as an example. What are some of the other ways this technology can be used by the federal government?
So we know that NASA, for example, is looking into using the technology to determine when pilots and air traffic controllers might be more prone to make a mistake based on the brain activity that they're able to sense using a brain computer interface. The Federal Aviation Administration, or the FAA, is also beginning to do some research into how they might medically certify pilots who one day might use a device like this to control an airplane. And the Department of Defense is looking into it for hands-free control of in a variety of situations, such as, for example, controlling a drone on the battlefield. It could be a great advantage if a soldier, for example, that's moving across terrain with his troops, is able to control a drone that's ahead of them scouting the terrain while also holding his weapons. So that's an area of research for the Department of Defense.
On the other hand, though, there are security concerns. Can you spell out some of those?
Certainly. Anytime that you're collecting personal health data, and our brain signals are personal health data, then there are concerns about those data being hacked or misused in some way. There are also concerns about ethical uses. It has been envisioned that a brain computer interface might be able to actually confer enhancements on a normally functioning human. So rather than trying to help somebody who has a disability overcome that disability, it could actually be used to take a healthy person and enhance their capabilities beyond the normal human limits. And that raises ethical concerns, of course.
And going back to the security concerns, what could a hacker do with access to people's brain data? How could it be misused?
So there are a couple of thoughts on that. One is that in the future, brain data may be translatable or usable in a way that it isn't currently. So right now, we don't know what people might do with those data, but the fact that they could collect them and store them might make them usable down the road. The other concern with hacking is that you could actually send signals into the brain computer interface theoretically and perhaps change the way somebody behaves or change their motions by interfering with or sending in false signals to the device.
And Karen, is there any type of regulation for this technology? And should there be?
So currently, the only devices that are in sort of marketplace use are the biomedical applications, and those, of course, are regulated by the Food and Drug Administration. Any medical device that's designed to treat a health condition, such as, for example, helping somebody rehabilitate and regain control of a limb after a stroke, that would be regulated by FDA. But if the device is being used for a non-medical purpose, at the current time, there are no regulations for that. So they're being used, for example, or tested at least in the gaming sphere. And then some of those other federal agencies, as I mentioned, are researching or looking into how they might be used, but they aren't yet regulated in those spaces.
And what other policy considerations did you identify regarding this type of technology?
One of them is that these are not plug and play devices. And I think that's a little bit of a misconception on the part of the public, that you can, put on the headset for a wearable brain computer interface and immediately begin to control devices with it. In fact, everybody's brain signals are unique. So we all think in a different way. We might both, our brains might tell our hand to reach out and grab a glass of water, but my brain is going to create those signals in a different way than your brain creates them. So there's actually a lengthy training period for somebody to learn to use this device and for the device to learn what the user intends with their brain signals. So that's one challenge, is that there's really a substantial training period. In addition, there are concerns that the device might get it wrong, right? It's trying to interpret electrical signals, or in some of the newer devices, blood flow in the brain, and interpret what the user means by those signals and translate that into some sort of action. But maybe it misinterprets. So somebody who's paralyzed and unable to speak, for example, might be trying to give legal consent, and the device might misinterpret yes or no on whether they intended to give legal or medical consent.
All right, Karen, thanks very much for being on the program. Nice to talk to you.
My pleasure. Thank you.
Thanks for watching. If you enjoyed the video, give it a thumbs up and subscribe to our channel so you don't miss out on any future Government Matters interviews.